let's start it recording. So we're going to run this parameter variation experiment. We've defined 5 possible values of average illness duration, 10 possible values of infection probability. And what we're going to see here is different runs. Do you see them on your screen there? They're not showing up well visually here. There's actually a whole bunch of runs. I could see them on my screen from certain angles. Do you see them?
Yep.
Okay. Most of them are actually down here at the bottom, and the ones at the top, but if you look at your screen from an angle, you may see them. I'm going to actually constrain these to be a smaller subset, okay? Just so it's more likely to take off. I'm going to do it from 0.5 to 1.0, okay? Apologies, I just want to make sure you could see it more clearly. So, infection probability 0.5 to 1 point. Can you see it now? Okay. So what it's doing here, folks, it's simulating for infection probabilities of 0.5, 0.6, 0.7, 0.8, 0.9, and 1.0, right? 6 different values times 5 different values for the infection duration. And what you see is that it's run this model 30 times as a result. Okay? This is useful because this model, it can give you a sense of the possible variations. And unfortunately, you can't see it on the screen well, but it's kind of the envelope of it is kind of in this region. It has a lot of regularities. Okay, so this is an example of systematically varying parameters. But can I show you something else here? I'd like to change it back to the fixed values, and I'd like you to go down in this model to where it says replications, the replications area, and I'd like you to check use replications, and I'd like you to run it 10 times per so-called iteration. That means it's going to actually run with the current set of parameters 10 times over. These are the default parameters. What do you think will happen then? Do you think we'll get exactly 1 line out? Make it 50 instead of 10. What the heck? We'll run it a bunch of times. Okay, can we run it? Are you folks okay with that? Okay. So what do you see there on your screen? You actually see it indicated here too. Well, it's run it 50 times, but there's variation. It's not just one pattern. Why is that? Randomness, stochastics. So ladies and gentlemen, what we see here is a summary, and you'll find me talking quite a bit about this online. This is what's called a 2D histogram, and what this is counting is the depth of, or the darkness of a square. So this space is divided into squares. It's divided into squares delineated, or bins, divided into squares in time and in the count of people infected. And the darkness of a given square indicates the number of trajectories of particular runs where the model's trajectory went through that square. So if that trajectory went through a given square a few times, it might be lighter. If it went through many times, it would be darker. Okay? So it's running this 50 times and highlighting trajectories according to their darkness as to how many times those trajectories were reached. And what you will find is that there's a band. Around a central point, there's kind of a band which actually varies. And looking at my computer, I can actually see is kind of an envelope down like this and up like this. It's not really well brought out on the screen. Can you see it on your screens a little bit better? Especially if you look at an angle. For some things about the LCD technology, you have to look at an angle, and you'll see that it's it's actually a bit wider than you might see initially. So this is dealing with stochastics. Remember, I said these models, to develop confidence in their results, you want to run it many times. Remember that? Well, one way we saw to do that is just run it again, run it again. But a more graceful and scalable way is to run the model many times using this parameter variation experiment. And even if you run it with the same set of parameters, you do so with many realizations, many so-called replications in any logic, okay? And you can specify those for a parameter variation experiment. So, I had this parameter variation experiment that we added to my model earlier, and we could have said here in the, this is the model we created this morning, and I could have said use replications, run it 100 times. But the problem is I didn't have any outputs that would summarize those results. And if you want outputs to summarize the results, you normally use this thing, a parameter, a histogram 2D. That is available from the palette, ladies and gentlemen. Here, some of you may have seen it. There's a histogram 2D data, which actually stores the data, and then a histogram 2D chart. And if you run this thing here, you will find, and I'm going to run it here, that you can actually export these things very, very easily. Okay? So having run this, it's still running it here, but you'll notice that if I say right-click on this and I say copy all, and then I go into Microsoft Office, for example, okay, Microsoft Office, and I go into Excel, I can go paste the results of that parameter variation. Ooh, that was a predictor trajectory. I didn't want to do that. What I wanted to see is the parameter variation, the histogram 2D data on which this is based. And I thought, oh man, that is not the format I expected. If you go to the data object, you should be able to actually copy all the data for this and paste it into a spreadsheet. And that would actually record the data behind this, okay? Sort of the bin counts for each of these bins. That's strange that it's not, you could do it that way. Okay. Okay, so that was a bit about parameter variation. Any questions on that before I go on to talk a little bit about calibration? What time do we have to finish, Jeff?
I think when the audience disappeared. Nationally 4:45, and there is afternoon tea as well.
Oh, is there? Is that served?
Probably wasn't. Yeah,
Okay. Would people like to break for tea? Okay. Get a stretch? Good.